going to demonstrate how to use functions with reference variables in C++. First, let's look at the default way of working with functions, and that's pass by value. Then we'll change it up and making them pass by reference. I began my program by including the IOStream and the vector libraries, and I started my main function. Inside of main, I'm going to create an integer variable named rabbits. And I'm going to go ahead and display the value of rabbits right away because I'm going to be displaying this several times as we work with it. And I'm in the main function. I suppose it's probably more correct to say main with the lowercase m because the main function is spelled with the lowercase m. All right, I have 5 rabbits and I'm going to display that in main. Then I'm going to call a function named passByValue and I'm going to pass the rabbits to that function. So let's create that function. It's not going to return anything, so we'll use void as our return type. And I'm just going to call it passByValue so it's really clear what we're doing here. And we're going to pass it a single integer. And then once we get that integer in this function, we're going to multiply it by 5. And then I will display the value of x on the screen. All right, and now let's add the function call to passByValue. And I'm going to use my rabbits variable as the argument into this function. So rabbits begins with a value of 5. I'll display that. We're going to call passByValue by passing the rabbits to that function. That function's going to take the value of rabbits and multiply it by 5. Display that value, and then when the function returns, let's display main's value one more time. And let's see what happens to the number of rabbits in main. All right, so this program executed, and right away it printed that we had 5 rabbits in main. Then we called passByValue. PassByValue multiplied the number of rabbits by 5 and displayed a 25. But when we got back to main, rabbits were still 5. And the reason for this is by default we are passing this variable's value by copying it from inside of main, copying the value 5 and giving that copy to the function passByValue. PassByValue can do anything it wants to the variable's value, but it's only modifying its own copy. But sometimes we do want to modify the variable that exists in the calling function, and in that case we're going to want to use passByReference. So I'm going to create another function, and it's going to work a lot like this one. In fact, it's going to be so similar that I'm going to just do copy and paste, and then change a couple of small things. All right. First of all, I'm going to change its name from passByValue into passByReference because that's what this function is going to do. And the way we do this is we want to indicate to C++, don't give me a copy of the variable, instead give me an alias or a reference to the original variable. And I'm going to indicate that with an ampersand. This is similar to using pointers, but it's a lot easier to work with than pointers. So now, just by adding that single ampersand, I am now going to be passing a reference to the rabbits in main. And when I modify it, I'm not modifying a copy of it, I'm actually modifying the value in main. So to see that, I'm going to put in pass by reference, and I'll pass my rabbits in. And then I'm going to display the value once more in main. So I'm going to see the initial value of rabbits, the value after pass by value is called, and then the value after pass by reference is called. All right, and what we see as the difference here is the value was still 5 in main before I called pass by reference. But when I called pass by reference, I was modifying the rabbits inside of main, not a copy. And so I multiplied that by 5. I'm actually changing rabbits from 5 to 25. I modified the one inside of main, and now that the function calls return, main displays its value and it shows that it's now 25. Let's talk about why we might want to pass variables by reference. There are several situations in which this can be handy. And one would be if I want to write a function where I get input from a user and I want to get more than one value. A function can only return a single value, and I may not want to write a separate function for every thing I'm asking the user. So instead, I can create a function with 2 reference variables, ask the user for 2 values, and then modify the values that were in the calling function. So it's going to look something like this. Let's say I want to ask a user for a length and a width so that I can do some geometry calculations. And I'm going to put that code in a function because I'm trying to write modular programs and not clutter up my main with lots and lots of lines of code. So I'm going to create function void get dimensions. And it's going to be passed 2 doubles, but they're going to be reference variables, or references to the original variables. First one's length, and the second one also a reference to width. And I'll fill out that function in just a moment. But I first want to look at how this is going to work in main. Now, if we're going to be working with 2 doubles, I need to create 2 variables in main. So I'll go ahead and create a double of length and width. And these don't have to have the same name as the parameter names in the function. I just happen to give them the same names. And main is going to call get dimensions, and it's going to pass length and width to get dimensions. And nothing's going to look different in the function call, but because we have the ampersands up in the function header, instead of copying length and width to the function, we're going to end up giving that function references to the original values. Now I can get the values from the user. There's a prompt telling the user what I want. And then I can get these 2 values from the user. And I really don't need to return anything here because I'm modifying my parameters directly. Well, let's see how those are modified by adding a line in main to display them after the function call. All right, so I'm going to test this program and then we'll come back and look at that function a little more closely. I still have all of my rabbits going on, but here I'm going to enter a length and width of 5.1 and 17.2. I don't know. And then when I'm back in main, I'm displaying the same values. Let's clean all this up here. So, let's try that again. Inside of main, I have two variables, length and width. I call getDimensions, and I'm passing a reference to these particular variables. So this parameter length is an alias pointing back to length, and width is referencing this width. So now when we get these two values from the user, we are saving what they enter in the variables that are inside of main. So that's a way of changing the scope of that variable. Normally that function would not have any way to access the variable in main, but by passing a reference, I'm letting an outsider have access to one of my local variables. So we just saw how we can use references in a function to allow that function to modify multiple values. Another good use of references is if we have a large variable that we don't want to make copies of. Once we start working with large amounts of memory, we don't want to be making lots of copies because that makes our program more inefficient. So over here in main, I'm going to define a vector of integers. I'm going to put int in the angled brackets. I'm going to call it numbers, and I'm going to have 1,000 numbers set to the value of 1. So this is not a tiny little variable. And if I want to call a function and give it this vector, I don't want to make a copy of the whole vector for the other function. So I'm going to want to use references when I'm working with this vector. So I'm going to call this the vector function. And we're going to pass in a vector of type integer, and I'm going to call it v. All right, and I'm not really going to have this function do anything, but what I want to do is use this function in a way where I'm passing a reference to the vector. Well, we're first going to make our function call. And if I call vector function, the way I have this written right now, I am going to make a whole copy of the entire vector numbers, and I'm going to give a copy to vector function. It's going to have its own copy. In fact, what we could do is we could say vector at 0 equals 500. I'll change the first element. V. There we go. So I'm going to change the value of the first element of this vector. I'll call vector function, and now let's display that first element. All right. Well, let's go ahead and run this program, even though we haven't written it in a very good way yet. And what I can see now is it went to the vector function, but when it returned, the first value was unchanged. And that's because the vector function got just a copy of the vector. It had its own copy, it could modify it, we're not modifying the one in main. Now I want to change this function to, instead of having a copy of the vector, I want to pass a reference to the vector. So all I have to do is add the ampersand between the data type and the parameter name, recompile the program, and now after vector function runs, I can see that the first element's value has been changed, so the vector function was modifying the values in main. Now, of course, if I want my function to modify the variable in main, I'll have to use references. But here I have a large vector, and maybe I'm not interested in modifying the vector. I just want to use references so that I can avoid making copies. So instead of changing the first variable, I'm going to say cout. And what I'm going to put in here now is I'm going to put the word const. And that tells the function, yes, you're going to get a reference to the original variable wherever it was created, but you can't modify it. Because just because I'm giving a function a reference to my large vector does not mean I want that function to necessarily modify it. In fact, if I try to modify it, it's not going to work. I can say v.at0 equals 500, and this is not going to compile. I can see that v is underlined, and it's going to tell me that the expression must be a modifiable L value, meaning the left-hand side of the assignment, the v.at0, needs to be something that can be modified. And right now, the vector is a constant, so we cannot modify the vector. So I'm going to comment that out and say, this does not work. All right, let's try and run this one. Okay, and it looks like everything's working correctly. When I'm in the vector function, I'm printing that first element, and when I return from the vector function, I'm printing it again. Of course, we never modified anything, so it always has a value of 1. But what we have done with this function is we used pass by reference with our vector because our vector is a large data item and we don't want to copy it. But if it's a function that's not allowed to modify the vector or any variable, all I have to do is put const in front of that variable data type or parameters data type, and now the function cannot modify that particular parameter. So reference variables or passing by reference to function are handy if we want the function to modify the value in main. Maybe we need to have the function modify multiple values, such as getting user input from more than one variable, or when we're passing large variables around, we don't want to make a bunch of data copies.